calculation, we need two more things.
I just did.
You did? Okay. Maybe I should take some water. I'm fine. Start.
Good deal.
So the third thing we need, now that we talked about this direction, either it's going to be two-tailed or one-tailed, we are done with that. Third thing we need to learn this alpha level. When we are looking at the probability of something happening, then we need to look at the level of significance. It is always noted by this thing called alpha. So that is the probability level decided by the researcher. And the alpha level determines the point at which the null hypothesis should be rejected. Let me give you an example first. And explain why we need this alpha level and what it means in terms of two-tailed test or one-tailed test. When we talk about this alpha, especially in hypothesis testing, if you look at the same section, line number 3, toward the end, either we set it at alpha equal 0.05 or alpha equal 0.01. We rarely set it at 0.000001 simply because I tell you why. Because if you look at the z-score table, the highest we can go up to what? Z-score will be 3.11. That's the highest one we can go for. Look at the table. That's the last one we have, 3.11. And if you look at the tail, column number C, the smaller part, it goes up to 0.0009. Now, if we are going with alpha levels equal 0.001, and if we are dealing with a two-tailed test, that means that 0.001 will be divided equally on each side of the tail. The same thing here. If we are dealing with alpha equal 0.05, that's the level of significance. Then 0.05, and we are dealing with this sign not equal to, that means we are looking at the right tail and the left tail both. So that 0.05 will be divided equally between this tail and this tail. So on each side we will have what? 0.025. Am I right? And here also 0.025. If we have 0.01 and we are doing a two-tailed test, 0.01 divided by 2 will be 0.005. So if we are using 0.01, then this side will be 0.005 and this side will be 0.005. So now the question is, how does it help us in rejecting or accepting or not rejecting a hypothesis? This is the significant level. That means when we are using this alpha, this area under the normal curve is 0.025. This area under the normal curve is 0.025. And we know the whole thing is what? The whole thing under the normal curve? 1.0. So when we are calculating these, looking at the z table, we have to find out the z-score for this point here and the z-score for this point here. So how do we find out the z-score for this point when we are using alpha equal 0.05? Two-tail. 0.05 divided by 2 is 0.025. Let's look at the z table here and see, look at the column number C. Column C here. Look at page number 226. Page number 226, column number C. and tell me where you find this value 0.025 and the corresponding z-score. Look at the third column, 0.025. Look at this side of the page.
1.96.
Yep. 0.025, column number C. If you look at this column here, right there, you find the value 0.0250. That's 0.025. And the corresponding Z value of this point is 1.96. That is here, this is 1.96. Now, this will be the same thing here. Here also we have 1.96. However, since this is on the left side of the card, we will have a minus sign in front of that 1.96. Now, at this stage, what it is telling you is, okay, we are using alpha equal 0.05. We are using a non-directional test. That's why we are looking at right tail as well as left tail of this normal curve. Now, because we are looking at both tails of the normal curve, this value 0.05 is equally distributed on either side, either tail. So 0.05 divided by 2 is 0.025. So now we need to look at this table, column C, and look for this value and then get the corresponding Z value for that point. So we looked at this table, 0.025, and we found that column number A, the Z value is 1.96. The right side is always the plus side, the left side is always the minus side. That means now we are going to find out the issue. Okay, let me backtrack. Now the issue is, when we are going to do the actual calculation, the value we obtain from that calculation, the value should fall within minus 1.96 and plus 1.96, between these, because this is the rejection area. That's why the alpha is there. Alpha, whenever using these two tail, this is the rejection area. So it has to fall within these. So minus 1.96 and plus 1.96. If it doesn't fall within this value, then we reject the null hypothesis. So before we can even reject the null hypothesis, now we have to do the calculation. So how do we calculate? And for the calculation, look at all right, let's do the calculation. How are we doing? We need to stop and then start it on again.
You have 2 minutes. Okay.